everyone, welcome back. Today is a very sunshine day in British Columbia, and it looks like a summer already. I can feel the heat. I wanted to open the fan, but I'm afraid that the sound will affected by the fan, so I have to turn it off. So I have to bear with the heat. Anyway, I still try to give you an interesting lesson today about the word problem related to the rational function. And this is the final touch for our unit in pre-calculus math 12, because you have already learned how to solve word problem related to rational function in pre-calculus 11. So this is just a little bit touching to have you to review what you learned and relate it to our real life problem. So let me read the question out loud to you. Tom is paddling in the Vancouver Island. The current flows at the maximum of 3 kilometers per hour. Write a function that related time in t hours. It would take Tom to paddle 8 kilometers, depending on whether he was paddling against or with the current. If he could paddle at 6 kilometers per hour with no current, state a reasonable domain, graph the function, explain how general shape of the graph related to the question. Here you go. You see that mathematics related to our real life. In this question, we have to base on the situation to model our own function. So we build our own function based on the data given. Let's do that together. First, let me write it down for you. What is the important number we should remember when we're dealing with the word problem? So I underline this 3 kilometers per hour. And what is it? This is the speed of the current. So let's see, represent the speed of the current. C equal 3 kilometers per hour. Now, when you swim in the swimming pool or in the river, right? There is a speed of the flow of the water because the wind, right? So sometimes, and we call that is the current speed. So in this Vancouver Island, the current speed is 3 kilometers per hour at that time, right? It could be changing depending on the wind changing direction as well. Also keep in mind that your speed or the boat speed in the still water will be affected by the speed of the current. So sometimes if your boat is went together with the current, then your boat will increasing the speed because the current will push your speed going up. If you go against the current, then the speed of the current will make your speed going down. Your boat in the still water, the speed of the boat in still water will go down, will slow down because your boat goes against the current. So that's the situation. It sounds like complicated, right? But that's how its real life is. So we have to, our task is what? We have to write a function that related t in time. So our function have a title of t. Now, t of x or of whatever we want to put our variable in here. Usually we say of x, right? Just put x for now, we can change it later, right? And we're gonna write this down, right? That's our job. It would take Tom a paddle 8 kilometers. So Tom paddled around the Vancouver Island. Sometimes go against with the current, sometimes go with the current. And he paddled for 8 kilometers a distance. So let's put D equals a kilometer. D represent distance in distance, right? What else do we need to write out? If he could paddle at 60 kilometers an hour with no current, so the fact the statement say with no current, we know that the boat speed, right? The boat, so speed of the boat equal 6 kilometers per hour. Without the current, it means the boat speed in the still water when it hasn't affected by the current. State a reasonable domain. Graph the function. Okay, so we have to think about domain. And how do we establish our domain? So we have to know the domain. What is the domain? Now, usually domain stand between somewhere to somewhere, right? Like from minimum to maximum, right? So let's say our domain is minimum less than or equal D, right? Domain, D represent for domain, right? Not the distance, right? This is be careful, right? Because, so let me put a small d for distance and the big D for domain. So let's distinguish like that, right? And maximum. So let's think about it. Now, usually the speed of the boat here will be somewhere between minimum and maximum, right? So it could be 6 kilometers. Now, if he goes against the current, it means we can take away -3. If he goes together with the current, we'll add 3 into this speed. So basically, this speed is between, let's say we call this one letter, and we call a velocity letter, right? A letter unknown, because we don't know this velocity flexible, right? Sometimes we add 3, sometimes we take away 3. And we don't know, we might add 3 or we might add 2 only, because depend on the tide as well, right? It's flexible between the tide as well. Or maybe we can subtract, instead of subtract 3, we might subtract 2 or might subtract 1 only, right? So therefore, we put in this below in this domain. And the minimum for this, if you subtract 3, it will be 3 kilometers. And the maximum for this, it will be 9 kilometers for sure if you add into 3, right? So the velocity here is then flexible between 3 and 9. But maximum is 9, so the V here have to be smaller than 9, but have to be bigger than 3. Because if we take away 6 kilometers, take away 3 kilometers, is minimum is 3. So the V here might have to be bigger than 3, but less than or equal 9. Let's put an equal size here as well, okay? So here, that's the deal. This V is flexibility, and we don't know between 3 and 9. But we want to demonstrate it in the way that it could be, we take away could be -1 or -2, or we could add into 1 or 2 up to 3, right? We don't have to add just 3, or we don't have to take away just 3, right? And therefore, let's establish the domain like this. So the domain in the way that -3 less than or equal V, right? Less than or equal 3. Add 3. So this V here is flexible between this limited, right? Between -3 and 3. So now our function of time will be related to time. Now in physics, in elementary physics, you know that if you want to find the distance, you use time multiplied with speed. If you want to use time, you will distance divided by speed, right? So that's the basic formula. So time will be distance divided by speed, or v. V is velocity. So based on this model, we're going to establish our rational function t of a number, let's say a number of x. And our x is in this velocity, right? Now I put v, so maybe I change this, become v, so t of v instead of t of x, right? Will be equal distance. Now, do we know our distance? Yes, our distance is 8 kilometers, right? Let me put a small d so that we're not confused. So d equals 8 kilometers. Now this is not flexible. We know this is a fixed number. Tom paddled only 8 kilometers around the Vancouver Island. He not paddled more than 8 or less than 8, right? So that's a fixed number. We substitute d by 8 divided by the speed of his boat in still water is also a fixed number. It's not changing at all, right? So divide by 6. However, the v here is changing between this domain. So sometimes we will add the v in here. Sometimes we have subtract the v. But because we already define our domain between -3 and +3, so we can just say add v in here. Now, if v is -2, then 6 minus 2 is 4. If v is +3, then 6 plus 3 is 9. If v is -1, then 6 minus 1 is 5. So this is the the speed flexible between this domain, right? So that makes sense. That is how our established rational function look like, because we know that this v is the flexible in between, could be 6 minus 2, could be 6 minus 1, could be 6 at 1, or could be 6 at 2, or maximum is 6 at 3. So therefore, this is the best model we can model our situation in this word problem. Okay, so that is a rational function. Now, let me do the next step. So this is we answer the first question, right? What is it? Write a function that related time in t hour. So this is, we write, right? What else? State the reasonable domain, and here is our reasonable domain. So this is the first answer, this is second answer, right? This is our answer. Let's frame it. Explain, draft the function, explain how general shape it look like. Now, if I draft this function, I'm going to draft it very quickly, right? We already learned how to sketch it. So I'm going to do it very quickly here. So let's say if we have a rational function, next part, I'm going to show you how we wrap this and how we interpret the function related to all the data given from here, right? I just erase it so that we have the room to sketch this one. So let me sketch the function. So we're going to have a function. The y function go like this. And let's say we have an axis like this. So this is the y-axis, but in here, the same like the time, right? The function of time, so that it will be t. And here is the axis, but instead of x, it will be v, right? It will be the same thing. Now, we know that our rational function have a vertical asymptote at -6, because -6 at 6 is 0, right? That therefore we have vertical asymptote at -6. So let's say -1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7 right here. So our asymptote is right here, minus 6. So the asymptote, instead of the y-axis here, we move to the left 6 unit, right? Vertical asymptote. What is our horizontal asymptote? Our horizontal asymptote, we look at when the V getting very large. This means we have an 8 number divided by a large number equals 0. So our horizontal asymptote is not changing. It's in below this, it on this number line, right? Is the horizontal asymptote. Now we take advantage of the invariant point, right? Of 1 and 1 in the basic function, and minus 1 is the invariant point of the rational function. So we take advantage of that. C1, this is 2, this is 3. Okay, this is 1. Then we're going to calculate the invariant point for our new function will be 1 for the x minus the 6, which is minus 5. And the y, so this is the x, right? And the y coordinate will be 1 times with a, because this is the vertical stretch by factor of a, so equal 8. So our invariant will be 3, 4, 5, 6, 7, 8. Go up here. So minus 5, this is minus 5 right here. So the coordinate will be minus 5 and 8, right? Minus 5 and 8. This is the new invariant point. And I think, okay. So minus 5 and 8. Minus 5, 3, 4, 5, 6, 7, 8, up to here. Wow. So this is our invariant point. So it looks something like this shape, go through this, and going down, and somewhere is somewhere like this, right? And it go along, shape along with this, like this. That's our rational function. And down here will be minus 1 times with minus a. So 1, 2, 3, 4, 5, 6, 7, a, minus a somewhere here. So our new invariant will be minus 1 add to minus 6 and minus 7 right here and down here. So it's about here. So it's something like this. Okay, that's a new invariant point. Okay, so let's interpret it. Let's assume if V equal minus 2, then we have the situation T will be equal what? T will be equal 8 divided by 6 minus 2 is 4, which is 2 hours, right? So if V is minus 2, this is minus 1, minus 2 right here. So yes, this point will show us T will be V equal minus 2 and T equal 2 hours. So that's how you interpret it, right? Right here, this point right here on this graph. Now, if V is minus 1, what happened? The hour will be shorter than a little bit because that will be 8 divided by 5. And 8 divided by 5 is how much? 1, so 3. So 1.66 something, 3 over 5. So let's see. Yeah, so more than 1 hour, a little bit. So it's right here. So it's somewhere like this, right? So that's how we interpret the graph. What else? If V is let's say if maximum V is 3, 1, let's just say 2. Then A divided by A will be 1. So actually, at 2, it should go above this a little bit. So it goes somewhere like this. Two and 1. And the wrap should be look like shaped like this. So that's how we get the wrap and we interpret it, right? If V is 2, 6 add 2 is A divided by A is 1. So it's right here. 2 for X and 1 for Y, for our. So that's how we sketch and interpret the graph, and looks seem to be all right. So here is how we model the situation, right? Given data, and we based on that, we establish our own rational function. Here you go. We are mathematicians. We write our own function. We don't even have to look at in some textbook. They write the function for us. We establish our own function based on how we interpret the information, how we process, how we analyze the data in the word problem, and we'll be able to come up with our own rational function very much accurately, right? Okay, so I hope you enjoyed this video. Thank you for watching, and stay tuned for our next video. Will be about the new unit of pre-calculus math 12. It will be polynomial function. Thanks for watching, everyone. Bye for now.